Hi everyone. We just reviewed how to calculate both luminous range and geographic range. Now we're going to put it all together and compute visibility for a specific light. We're going to review two example problems, one in which luminous range is greater than geographic range, and one in which geographic range is greater than luminous range. Now remember when we talked about computing visibility to a light that there were 4 data points that we needed every time? One was the height of the light. The other was the height of the observer, right, from the ship. Then we needed the nominal range of the light and also the meteorological visibility. So we'll run through this problem here and we'll see if we can find those 4 bits of data. So in clear weather, for an observer with height of eye 50 feet and light with height 100 feet and nominal range 26 miles, we need to calculate both the geographic range and luminous range in order to determine computed visibility. So as I went through, first thing I noticed is clear weather. So that's our meteorological visibility. Anytime you see clear weather, we know that equates to a meteorological visibility equal to 10 nautical miles. Next up, we're given a height of eye 50 feet. So that's the height of the observer from the ship, and that's equal to 50. Good news is it's given to us in units of feet. So when we plug that value into our equation when we're calculating horizon distance, we don't have to do anything else. We know it's going to work with that factor of 1.17. Next up, we're talking about light height of 100 feet. So the height of the light is equal to 100 feet. Again, that's in units of feet, so we know we're good there. Finally, we have nominal range of 26 miles. And we know that nominal range is always in values of nautical miles, right? So 26 nautical miles. So first we're going to calculate geographic range. Just remember though, with these 4 data points, when we're calculating geographic range, we're going to use heights. So height of eye of the observer from the ship and the height of the light. So these 2 values are going to go into our geographic range calculations. And then we're going to pull out the luminous range diagram and use both meteorological visibility and nominal range values to determine our luminous range. So first, let's go ahead and calculate geographic range. So again, we know that geographic range is equal to the horizon distance of the observer from the ship and the horizon distance of the light. So the sum of those 2 values equals our geographic range, where the horizon distance of the observer, in this case, we know it's 1.17 times the square root of 50. Okay, and again, units of feet, so we're good for this 1.17 factor here. When you plug that into your calculator, you should get 8.3 nautical miles for your horizon distance of the observer. Next, we need to do the horizon distance of the light. Same formula, 1.17 times the square root, in this case, 100. Right, so 100 feet. And again, units are good. They check out. When you plug that into your calculator, you're going to get a value of 11.7 nautical miles. Now, to get geographic range, again, it's the sum of both those horizon distances. So we'll get 8.3 plus 11.7. Geographic range, 20 nautical miles. Okay, so we've solved for geographic range. We're good to go on that. Geographic range, 20 nautical miles. Next, we need to solve now for luminous range. And again, so we're going to break out our luminous range diagram found in Bowditch, also found in the front matter of list of lights or light lists. So here it is. As you can see, again, I'm just Xing out those weather synoptic numbers just so I don't confuse those accidentally for the meteorological visibility distances on those range arcs. So first we're going to start off with, we were given a nominal range, which we're going to input on the x-axis, of 26 nautical miles. So start from the bottom, find 26, and then we're going to draw a vertical line straight up, connecting it to 26 at the top. Now we need to apply the meteorological visibility. In this case, we were told it was 10 nautical miles. As you can see, that's not one of the standard arcs, It's going to be somewhere in between the 11 nautical mile arc and the 5.5 nautical miles, probably much closer to the 11, I would say just below it. So as I estimate where it's going to be just below the 11 nautical mile arc. And then what I'll do is where those two lines intersect, I'll draw a dot and then a horizontal line over to read out that value. It's just above that 25 nautical mile tick, so it's 26 nautical miles. I showed you that on here just again to kind of reinforce this concept, but remember, whenever you're told that meteorological visibility is 10 nautical miles, you know your luminous range is going to be equivalent to your nominal range, because all nominal range values are based upon 10 nautical miles of visibility. So really, knowing it was in clear weather, aka 10 nautical miles, we wouldn't have really even need to bring this diagram out. We could have just instantly known that, hey, nominal range is going to equal the luminous range, so therefore luminous range is also 26 nautical miles. But there we go. We did it both ways just to show. So now we have geographic range equal to 20 nautical miles, luminous range equal to 26 nautical miles. Computed visibility will always be the lesser of both those values. So in this case, our computed visibility would end up being 20 nautical miles. So the next example, the only thing that's changed for this one is going to be visibility. In 5-mile visibility for an observer with height of eye 50 feet and light with height 100 feet and nominal range 26 miles, we need to determine both luminous range, geographic range, so that we can calculate computed visibility. Again, the height of the observer has stayed the same, so we're on the same ship, so that's great. And the height of the light and the nominal range of the light are the same because it's the same light. The only thing that's changed, meteorological visibility has since decreased from the 10 down to 5 miles. So again, meteorological visibility in this case is going to be equal to 5 instead of 10. The height of eye, 50 feet, right? So the height of the observer, again, still the same, 50 feet. Height of the light is 100. So that light hasn't changed, same light. And the nominal range is 26. Okay. So good news here, when we're going to calculate geographic range, since we know geographic range are based upon the heights, and it's the same light, so the height has stayed at 100 feet, and we're on the same ship, our height of eye has stayed at 50, our geographic range calculation from before is going to be the same. So geographic range is still going to end up equaling 20 nautical miles. Now, what's going to end up changing is the luminous range value, and this is because not that the nominal range value has changed, but this is because the meteorological visibility has decreased from 10 miles to 5 miles. So let's go ahead and use the luminous range diagram again, and let's input these values. So again, x-axis, we'll do 26 nautical miles, and draw a vertical line straight up connecting 26 nautical miles. And this time we have to pick the 5 nautical mile visibility curve. Again, there is no 5 nautical mile standard visibility curve on this diagram, so we're going to have to estimate that'll be just below that 5.5 nautical mile curve, right around there. And then where that curve intersects the nominal range vertical line, we're going to place a dot, and then we're going to read that value out on the y-axis by drawing a horizontal line. In this case, we've determined luminous range is 15 nautical miles. So when visibility decreased by 5 miles, we now have, with this data from this problem here, geographic range equivalent to 20 nautical miles and luminous range equal to 15 nautical miles. So in this case, the lesser of those two values is your computed visibility. That ends up being 15 nautical miles. Next up, we're going to actually apply this to a chart and then run through one actual example with a real light from a pub.